Assalamu alaikum, I'm Afzal Badshah, and in this video I'm going to discuss what are the algorithms and how to calculate the complexity of the algorithms. When we talk about the algorithms, it means that it is a step-by-step procedure to solve any particular issue. And when we talk about the issue, when we talk about the problems, that it means that these are the such like situation which require solution. And when any problem requires solution, this means that this problem may have a number of solutions, but we use the algorithms. With the help of algorithms, we will select the best solution in terms of the complexity. This complexity of algorithm may be in terms of the running time or the memory required. I will give you one example. For example, if you want to travel from one city to the other city in your country, then there will be different routes. There will be different routes to travel from your current location to the next city. But you will select the best way. You will select the best route in terms of the time and in terms of the required fare. So algorithms and the problem solution is just like that. Algorithms may be used for to search any particular record. For example, the board has announced your result, the university has announced your result, and you search your roll number on the university website, or you are going to sort the record, and you may use the algorithm to insert, update, or delete any record. Here is one example of algorithm, and this algorithm is written to add two numbers. So how to add two numbers and how the algorithm will be written, you can see this is a step-by-step procedure. If we follow this step according to their series number, we will be able to solve the issue to add two numbers, otherwise not. So in the first step, we start okay we start to solve the issue, and after that we are going to initialize three variable a, b, and c. We are going to add ab, but we will require c to store the result of a plus b. So here we will define the values of a and b. For example, here I say that a is equal to 5 and b is equal to 10. And on the step number 4, I am going to add both these numbers, the 5 and the 10. And on the step number 5, I am storing the result of A and B, which is 15, into the C. And after that, I am printing the C, and after that, I am ending this algorithm. So this is the plain wording. It is a step-by-step procedure which is written to solve to add two numbers. During programming, you may use different languages. You may use C, C Sharp, PHP, any other language you want to use. By using this algorithm, you will be able to add these two numbers. But if you will change this step, the series of these steps, then you will not be able to solve the issue. For example, initialize the variable, and I bring this step into the end, or I bring the step number 3 to define the value of a and b after the c is equal to a plus b. Then you will not be able to solve the issue because there is no value in the a and b. So to follow the algorithm is very important, and if you don't follow the step, if you don't follow the procedure, you will not be able to reach to the destination. So analysis of the algorithm means that when we analyze the algorithm to count its running time. Running time means the time required to solve any issue, and the required space, how much space will be required to store its variables. Actually, the required space define the variables and the constant which is used in the program. And when we analyze the algorithm, we analyze in 2 points: pre-analysis and the post-analysis. Pre-analysis means before writing the program, when we write the algorithm, then we analyze this. We take its analysis to find out its running time and the space required. The pre-analysis is actually a theoretical work to calculate the running time, and the post-analysis is done after writing the program. You may write this program in different language, and you may run this program on the different machines to according to the language and according to the machine. After writing the program, after that, calculating the running time and the required space is called the post analysis. Here is one algorithm, and I will be going to calculate its complexity in terms of the space, that how much space will be required for that. It is just like that if you are going and you are taking a flight from the one city to the other city, then you call prior from your flight to the services to book 2 or 3 seats for you. So the company booked 2 or 3 seats for you. Okay, here you can see that I initializing integers a, b, and c. This is just like meaning to book your seats before the flight. So to require the space complexity in this algorithm, I am going to sum a and b, and you can see after starting the program in the second step, I am storing in C the addition value of a plus b plus 10. It means that there are 3 variables a, b, and c which is stored in the memory, and also the constant value is also stored into the memory. So to calculate the space complexity, the formula is space is equal to 1. 1 means constant and the 3 means the variable. We are adding the number of constant which is stored into the memory and also the variable which is stored into the memory. That means it required 4 spaces in the memory. And when we talk about the time complexity for an algorithm, that it means how much function this program will do and how much input will be given to the any particular program. Asymptotic notation is actually used to define the boundaries of algorithm, and when we define the boundaries of the algorithm with respect to the running time, then these are the best case, the average case, and the worst case. Best case is the minimum time required to execute the program, and the worst case is the maximum time required to solve any particular program. And the average case is actually the combination of minimum and the maximum, the best case and the worst case, and it usually take the average time of the best case and the worst case. Asymptotic notations are used to define the best case, the worst case, and the average case. Big O notation define the upper bound. Upper bound means the maximum time the program may take during executions, and it is also called the worst case. In the program, we usually calculate the big O notation. We calculate the worst case of the running time of any particular program. And theta omega notation show the lower bound. This means the minimum time required to run any program. This is the best case of the any algorithm. And theta notation is the average case. It shows the lower bound and the upper bound. So once again, the big O notation is actually showing the worst case, the maximum time required to run any program, and omega notation showed the lower bound, means the best case, the minimum time required to solve any problem, any algorithm, and the theta notation is actually the average case. It comprises both the upper case and the lower case. These are the graphs. In the big O notation, you can see that this is the function, this is the gn function, and this is the big graph for the big O notation. This is showing the time required, and this is actually showing the input. And when we give the input, with the input the time increases, and this is showing the upper bound. For the function fn, this means the maximum time which may be taken by that function. The second one is the omega notation. The same, this shows the time, this is showing the number of inputs. With increasing the number of inputs, the time also increases, and this shows the lower bound. This shows the lower bound, which means the minimum time required to solve this algorithm. And in theta notation, you can see this that this is also giving up upper bound and also a lower bound. The lower time required to solve this algorithm, and upper bound showing the worst case time required to solve any particular solution. So the in an asymptotic notation, how the running time is calculated? If actually in algorithm, we usually calculate the worst case running time. So for the casting is denoted by big O1, because the casting is run only for one time, and all the logarithmic is shown for the log n. And if there is a linear, for example, and a loop is there, then this will be big O(n), and for example the quadratic is shown by square, cubic is shown by n cube, etc. For the example, here I am showing one array, and this array is having different element. For example, this is having 8 elements, and I am going to calculate its best, worst, and average case. For its best case, for example, I am going to search one, and I will use any linear search algorithm to search the one. To search one, it will search this one in first iteration, and this program will be run only for the first time. So this is shown by omega 1. This means this is the best case. And the worst case is, for example, I am going to search 8, and when I will search 8, this will be run for the 8 time for the n, because they will compare the values with each other. So the worst case running time is O(n). And for example, I am going to search any 4 or 5, then the running time will be n divided by 2. So hopefully you will be able to define the best case, the worst case, and the average case. Thank you so much for watching. Allah Hafiz.